So looking at melting of glaciers. Melting of glaciers, all in all, reduces the amount of fresh water available for humans and for other living organisms. Because where does that fresh water, if melted, eventually flow into? Yeah, it flows downward to the lowest lying area, which are oceans. So therefore making it mix in with the oceans, making it now have salt. So it's not potable, not drinkable. So if you look here, we've got a couple different examples, like the McCarty Glacier in Alaska. You see it from 1909 to 2004, completely gone. Also, the Sperry Glacier, you can see it up here in 1913, now in 2008, completely gone. And a couple other examples here in 1941, not really sure where this is, but that glacier has receded dramatically as well. Another one here, completely frozen, not so much anymore, liquid here. And once again, this is another drastic effect of melting of glaciers. Also causes an increase in disease. With the warmer temperatures, you promote insect populations. And insect populations transmit a lot of diseases, like malaria, hantavirus. Malaria, yep. And West Nile, we got West Nile here. This is hantavirus. Hantavirus is a little bit different. You have rodents that spread the hantavirus, but malaria is a huge problem across the world in a lot of developing countries, developing countries in tropical regions. So get a lot of mosquito growth, more malaria, more problems. Increased weather. As you increase the temperatures, you also increase the tropical range. So say my equator is down here somewhere. As temperatures get warmer, the tropic ranges move upwards. So now you're going to have tropical storms hitting more frequently, like we had with Sandy hitting the Northeast. Biggest hurricane ever to hit the Northeast. Tornadoes will increase, extreme weather, and then also like the droughts that we saw last year, reducing crop yields. With the increasing of melting of the glaciers, you have water running into the ocean. And if that is continental ice, that water flowing into the ocean, you're going to have the sea level actually rise. And if that sea level rise, if we look at Florida here, if it increased by 1 meter, you can see some of the red areas is where water will go into. 2 meters, you can see almost the Everglades are completely gone. 4 meters, there goes Miami. And then 8 meters. And 8 meters, we've got Orlando, somewhere around, let me write a little dot, like right there. Orlando, I mean that's not the best color for that, let me do blue. Orlando, right there, it now becomes that nice city next to the beach. And the problem with that is when the water comes in so far, it displaces all those people. And where do people like to live? Yeah, they like to live on the coast. So you have the majority of the population living near this water, and displacing them, you're going to cause a huge migration of people. Also, another effect of it is mass extinction, which we've already been experiencing some of this. In the past, if you look over here, up here, we have had, we're looking at the number of families here in millions of years ago, we've had these dips in the number of families. Looking at fossil records and noticing there's not as much within that period, we've had these mass extinctions in the past. If you look at corresponding CO2 levels to those mass extinctions, we've got the mass extinctions here with the star, and then we have major volcanic activity here, and volcanoes emit a lot of CO2. So with more CO2, you're increasing your carbon dioxide in the atmosphere. So you notice with the peaks, or mass extinction here, mass extinction here, mass extinction here, and this line is carbon dioxide, what do you see? Yeah, you should see that there is a correlation between the quantity of CO2 in the atmosphere and the mass extinctions in the past. But a cool thing is, if you look here, is the number of species and the periods more present here, farther back here. what could you say about the diversity of life now versus any time period prior? It's more. So the diversity of life is actually at its highest it's ever been. And you can see that here as well, the number of families. It's at its highest peak. And that diversity is very important. With more diversity, you have more stable ecosystems, food chains, food webs, because they're able to support. You lose one species, you don't collapse the whole food chain. So that's good for anything, because if you lose something lower on the food chain, you lose food sources for other, and then potentially it affects always the concern as humans. With a increased population, reduction in food and water supplies, and pressure on developing countries to reduce their CO2, you're going to have an increase in conflict. Most conflicts are triggered by a reduction in food or water supplies. So if we look here at the world map, you can see the different conflicts in 2012. This is where conflict is happening. High probability. This is stable. This color here, and this is other. You can look to see that there's insurgency, different types of air or ground military actions, but majority of it, conflicts, come from food and water supplies. So with this increased temperature, you're reducing water, and you're also reducing food supplies. Then the last effect that we're going to look at here is a decrease in albedo. Remember what's albedo? It's the reflection of light. So if we have less snow and less ice at the poles, we're going to have less albedo, causing more absorption. So you can see here from 1980 to 2000 to 2011. What do you notice about the quantity of ice? It's reduced. And a lot of that ice reflects light. So if we're not having as much, we're going to have more solar radiation, infrared radiation absorbed.